In this video, I want to use the ratio test to show that the series with n squared over n plus 4 factorial converges, and then show that the series converges to 10e minus 163 over 6. Let a sub n be the expression n squared over n plus 4 factorial, and so a sub n plus 1 is n plus 1 squared over n plus 5 factorial. The ratio of a sub n plus 1 and a sub n will be this expression over this expression. N plus 1 squared is the same as n squared plus 2n plus 1, and then n plus 5 factorial, we can rewrite it as n plus 5 times n plus 4 factorial. And then this n plus 4 factorial, this factor, and then this factor n plus 4 factorial, they cancel each other out. So what's left on the top here is n squared plus 2n plus 1. And then we also get the n plus 5 times n squared, which is n to the third plus 5n squared. So the limit of the ratio a sub n plus 1 and a sub n as n approaches infinity be the limit of the expression n squared plus 2n plus 1 over n to the third plus 5n squared. And then let's divide everything here by n to the third. N squared dividing by n to the third is 1 over n. 2n dividing by n to the third is 2 over n squared, and then 1 over n to the third. N to the third dividing by n to the third is 1, and then 5n squared dividing by n to the third is 5 over n. And then we can see that as n approaches infinity, each term up here will approach 0, and then the 5 over n also approaches 0, so for the whole thing we get 0, which is less than 1. So the limit of the ratio a sub n plus 1 and a sub n as n approaches infinity is less than 1. And therefore, by the ratio test, this series with n squared over n plus 4 factorial converges. And now let's show that the series converges to 10e minus 163 over 6. Notice that n squared can be rewritten as n plus 4 times n plus 3, and then minus 7n minus 12. If we simplify this part right here, this is n squared plus 7n plus 12, and then minus 7n minus 12, then we get n squared. And then this is the, we can rewrite this as n plus, the factor n plus 4 times n plus 3 over n plus 4 factorial, and then divide, and then minus 7n plus 12 over n plus 4 factorial. And then notice right here, this is the n plus 4 factorial is n plus 4 times n plus 3 times n plus 2 factorial. The factors n plus 4 were cancelled out, and the factors n plus 3 were cancelled out, and then what's left is just n plus 2 factorial. And then for the 7n plus 12, I'm going to rewrite it as 7 times n plus 4, and then plus 12, and then minus 28. And so we simplify all of this, and we'll get 7n plus 12. So we get 1 over n plus 2 factorial, and then this part here, this is 7 times n plus 4 over n plus 4 factorial, and then this is minus 16. And then this is minus and minus, so we get plus 16 over n plus 4 factorial. And so the original series with the expression n squared over n plus 4 factorial, we can rewrite it as the series with 1 over n plus 2 factorial minus 7 over n plus 3 factorial and then plus 16 over n plus 4 factorial. And here are the first terms. So when n is 1, we get 3 factorial here, and then we get 4 factorial here, we get 5 factorial here. When n is 2, then we get 4 factorial, 5 factorial, 6 factorial, and so on. This is 1 over 3 factorial minus 7 over 4 factorial, and then plus 1 over 4 factorial. And then notice that this is 16 over 5 factorial minus 7 over 5 factorial, and then plus 1 over 5 factorial. And we get 10 over 5 factorial. And then the same thing for all of the terms with the 6 factorial in the denominator. 16 minus 7 plus 1, we get 10. And then if we look at all the terms with the 7 factorial in the denominator, we get 16 minus 7 plus 1, which is 10 over 7 factorial. And then the rest of it is just 10 over a factorial, not 10 over 9 factorial, and so on. The first 3 terms here is negative 1 over 12, and then the rest of it we can rewrite it as 10 times all of this. Recall the power series representation for e to the x is 1 plus x squared over 2 factorial plus x to the third over 3 factorial, and so on. E to the first, so let x be 1, we get e to the first is 1 plus 1 plus 1 over 2 factorial plus 1 over 3 factorial, and so on. These 5 terms right here is 65 over 24, and then here is the rest of the terms. So we get e minus 65 over 24 is equal to this. We have just shown that the series with n squared over n plus 4 factorial is negative 1 over 12 plus 10 times this series right here, starting with 1 over 5 factorial. But this part here is e minus 65 over 24. And then simplify, we get 10e minus 163 over 6, which is approximately 0.016151. And so, in summary, we have shown that the series with the expression n squared over n plus 4 factorial, we've shown that it converges by the ratio test, and that it converges to 10e minus 163 over 6. And that's the end of the video.